Welcome friends, in this video we will be discussing about a non-ideal switch, and we will come to know how a MOS can act as a switch. In the previous some videos we had talked about how the MOS acts as an amplifier. We'll discuss about the different modes of the amplifier a bit later. First we need to know that how the MOS acts as a switch. We had studied that when the MOS acts in the saturation region it acts as an amplifier, but when it is in the cutoff or the linear region, then it acts as a switch. So this is how a non-ideal switch acts like. This is how a non-ideal switch is. Let us explain each part of the switch individually, and then we will tell how this relates to a MOSFET. So the two terminals of a switch are A and B. These are the two terminals from which we want to transfer the data. Suppose we want to transfer the data from A to B. Okay, and there is a control terminal which is control terminal C. Okay, so what is there actually is this, that when the switch is off, this is the actual switch. Okay, this is the switch. This switch turns on or off based on the condition of my control, that is C. Based on the control C, the switch is either turned on or off. Okay, so suppose we have given a data at A and we want to have the data at B, and the switch is off. So this circuit is not transferring any data, or is the circuit is open circuited. So from where does the current go? Actually, if it is an ideal switch, then there should not be any current, there should not be any leakage current. But there is nothing called as an ideal switch. So a real MOS switch, there is a leakage current, this I off, which goes from this path. This is the I off path. Okay, the I off path. And there is a resistance, the off resistance, that is called the R off. So during the off state, the MOSFET also conducts some electricity which is known as the I off, and there is also resistance which is R off. Right, now talking about when we turn the switch on, giving a condition to C, we have turned the switch on. So as this is a very high resistance and this is an infinite resistance, the current would not flow through these parts. It would flow through this part where it faces R on, which is the on resistance, and there is a voltage. This is the V on, which is a voltage that is lost while the current is flowing from the terminal A to the terminal B. This is because of the fact that when a MOSFET is transferring data, a few voltage is lost because of the charge feed through effect, which we will discuss in the next few videos. Okay, there is also a current loss or a parasitic loss that happens through the A to the ground, also the same from B to the ground. We will explain how these happens in context of a MOSFET in this video only. And there are capacitors, there are parasitic capacitors exist everywhere, between A and C, between A and B, between B and C, everywhere. Okay, these are the capacitors that are occurring, and this is the ground terminal. So this, my friend, is the diagram of a non-ideal switch. Now coming to the fact that how a MOSFET can act as a non-ideal switch. This is, suppose I'm drawing it a bit bigger, the structure of my MOSFET. Here is the source terminal, here is the drain terminal, the oxide layer, the metal layer, and here is the gate terminal. Okay, this is N plus doped, this is also N plus doped, this is my P substrate. Right. Okay, now the thing is that suppose, as we had discussed, consider this S as my terminal A and the D as my terminal B. So we need to transmit data from the source to the drain, that is from this to this. Okay, and the control terminal is my gate. Okay, so when a channel is formed, and information and electrons travel from this direction to this direction, and thus data is sent, the signal is sent. Okay, so we all know here a depletion region will be formed, which will be more thicker on the drain side because the reverse biasing here is quite more. The bulk is grounded. Now we need to talk about every part that was present out there. When we do not give any voltage to the gate, that is the switch is off, ideally there should not be any channel formed, the channel should die. But actually the channel definitely dies, but there is a leakage current flowing through this. There is a leakage current from where we get the the I off, and there is the resistance for the I off that we get, which is obviously quite high because there is not a channel formed. It goes through the depletion region, and that is my R off. When the channel is formed, and this is the channel is formed, so there is a resistance of the channel that we have studied, the Mosfet resistance as the R naught, and we get my current as my ion, which is my IDS, we all know. Okay, and for the capacitor parts, this is a PN junction, so definitely there will be a junction capacitor out here. This is referred to my CAC. There is also a junction capacitor out here, which is my B and C. Here also a capacitance effect is present. This is my CAB. So these are the capacitors, and due to this capacitor there is also leakage current to the ground from the source, which is my IA, and there is also leakage current through the drain, which is my IB. So this diagram is like totally ruined, so I'll draw it once more. That due to these effects the capacitors are present out here. Sorry, due to these capacitors the current that was drawn, the current blocks, the IA and IB are there, parasitic capacitors are there, the on resistance is there, definitely with the on current, and the off resistance is there with the off current too. So these are what we get out here. I hope it's clear as to how a switch is being formed with the help of a MOSFET. Hope you like this video. Please like and subscribe to my channel, and thank you for more such videos.